This hands-on session, we will be discussing programming language or a software tools, you can say it, which is R. So why R? Basically, R can be said as the language of data science. It was particularly developed for computational statistics, but then eventually in the last decades or so, it became the language of data science. And it is not my words. It was a survey of data mining experts, and they were asked the question which language they prefer when they are doing analysis of their data. And they particularly told R. And in fact, you need to overwhelmed to know that R was more popular than Python. In fact, 50% more popular than Python. So that's why we are discussing R. In case of computational statistics and in data science as well, it is the language, it is the most preferred language. But then the question will be why? Why R is so preferred language? There are many reasons, but I will put forward 5 of them. First, it is free. You do not need to buy anything. You will get everything for free, along with R and its IDE packages, everything. All are free. Next, it is open source. Open source means the things are getting that the packages, the contributions are getting from different communities. You are getting those all are free, and you can contribute with some packages in R, and these all can be done free. And there are 9,000 packages, 9,000 plus packages as of date, and they are all comes for free. And then all the operations are vector operations. That means if you have vector operations, means suppose you have one variable or you have 1,000 variable in one array or a vector, then without using any for loop or without using any kind of loop, you can get access or you can do works on those variables in only one line of code, because R supports vector operations. All the operations you are doing specifically on a variable are vector operations. So that's why R is so preferred language for data analysis or in computational statistics. And one more reason is that you do not need to have any idea of any programming language like C, C++, Java, like that. You do not need to study the programming language C, and use R as a software itself. And just like you are using any software like Photoshop or Paint, anything, you need to remember, or you can search for some basic formats, and you are free to go with R. So the language may not be actually studied or understood by students of non-computer science background. So let's see. So that's why R become more popular. So that's the kind of overview that we will be going to discuss about. First, installing and setting things up. Some basic things. We'll discuss about how to import and loading the packages. Take the data from the user, or take the data from different some commander, R commander, that will be interesting. And descriptive statistics, how we can use descriptive statistics, and comparing mean with the time parameters and the relationship and pattern. Okay, so first thing first, you need to download and install R. And as I said, it is freely available. So just let me share my whole screen first, because that when the R will be. Okay, so you can easily go to Google and type download R, and I think you are getting the first link, and that's why you are going to the CDAN link. And according to your operating system, you can download 64-bit or 32-bit Windows or any other operating system you can download, and very easy installation things are available. So I'm going detail into the installation. You can just click the default link and you are ready to go. Okay, and then you will be there in the R things like this, and this is the command window that will open first, or we will call it a console of R. Okay, so in there, if you need to find uh, help of any command that you do not know, or you want to know details about any command, you can basically type help, or with a question mark like this, we can also type, and it will be the web link of that command will open. Right here, I have typed like mean uh, question mark mean. So I want to know about the mean, the command mean. Do they do they mean anything, or what is the meaning of the command mean? I want to know. So basically, I just type question mark and mean, and it will take you to the page of the mean. And if you just see here, this is not a web page. Although this is a web page, but this is not fetching from the website. It is locally saved. So whether you are connected to the internet or not, you are going to have this description window open in your browser. So all right, you can also type like help me, and that will also take you to the same thing will be done. Okay. So now I will encourage you to download RStudio. R is good if you have a good ID in R as well, but then I will encourage you to download RStudio just after downloading and installing R. Why? Because first, it is convenient. It is a nice IDE, more better than far better than the R itself, and it is IDE. It is not a replacement for R. It is just an IDE, so integrated development engine. And the second cause is the consistency. Consistency means if you are moving from one operating system to other, or different version of operating system, some commands in RStudio or the options in RStudio may get changed. To bring the consistency, you need the RStudio. So and then the navigation panels are also very easily available in RStudio. Just for example, just for the sake of example, if you how to download RStudio, then just you need to in Google just need to type download RStudio, and you are to go here. Okay. So it is freely available. So you can choose your version, and for different operating system, you can choose the free version only. So that free version is freely available, and you can download and install it easily. And after installing, you will just open the RStudio. It will look like this. This is the window that this is the console window, and alongside this console window, as I said, the navigation options are very easily available in R. So the terminal, your jobs, all are easily available at your fingertip. Okay. So and the second thing, here at the right hand side, I will draw attention to the right hand side. Here you have other windows like your environment. For the time being, I will just clear those things. So this is your environment. That means your variables you are using will appear here. You can import the variable like here. You can import from different Excel file, SPSS, data, SAS, different statistical software. You can import their files in R and do your work. You have the history, that is the command history. I have used those commands from the module. So these are the command history. These things are for connecting your databases, and then you have tutorial. You can learn the use of R and RStudio by clicking the links here. So this is the window, second window that you have. Third window, here you have files, that means the folder where you are currently working, and you can change the folder, right? Or you can add the folder. You can go to home, you can delete a folder or add a new folder from this window itself. You do not need to go to your windows. Everything is available here. Then the second option is plot. I will discuss about different types of plots, and they will appear actually here, and you can export the plots from these options. Packages, I'll come to the packages. There are different packages. This is the packages that already, these are the packages that are already installed, and you can add some packages, update some package, and install some package from here. Type any kind of command. You can take help, and now this help is actually the coming inside the window itself. You do not need to go to your browser. So the help itself coming to inside a window. That's why I was saying that your navigations option are very easily available inside your art. And there is a viewer, and the things, the visualization will appear here whenever they will be discussed. And the next thing is this, the portion for coding. You can write different line of codes and save them in a .r file for future use. So those codings will appear here. The open codings will appear here. Now the beauty with R is that other than any unlike any other programming language like C, Java, C++, you can after installing R, you can go to the console and you can use R. You can use R as a calculator like this. If you just type any thing like any plus minus thing, you are getting the answer. You are doing any multiplication, plus minus anything, you are getting the answer from here itself. So those who are aware of the programming languages like C and Java like that can relate to these things, that you need to write at least 5 or 6 line of codes whenever you are in programming language like Java or C++. So there you need to write at least 5 or 6 line of codes for these things, for adding or using your or building any calculator. And you need to declare variables, and you need to take care of the type of the variable, data type of the variable. Like you have some integers, some floating point number, and you cannot just use the same variable for integer and floating point numbers. But here, as I have shown you, that you can use any kind of variable, whether it's a integer or floating. You can use any kind of variable irrespective of their size and dimension, and you are free to go with this calculator options. So you do not need to declare any variable. You do not need to bother about the data type of the variable. You can use this R function. But this is only the beginning. This is only the beginning. So this is not the purpose of the R. Just to use it as a calculator, which is not the purpose of any programming language or statistical software, right? So this is only the beginning. And also see these options. If you have multiple instructions, and you can write in a single line like this. If you have multiple instructions, you can write in a single line, and the line, after press and enter, the line will be executed, and all the 3 answers here. I have 3 instructions for all the 3 answers will be provided by R in line by line manner. So that you can do very easily. Okay. So these are the operational symbol for addition, operation, exponential. These are almost same to any other programming language. There is nothing much change. Okay. And for numbers, if you have a missing value or not a number, you can indicate those by NA or NaN. And then if you suppose have a variable X, as I said, every variable in R are treated as vector. So if you have a variable like this, and you want to take the mean, as I said, mean was taken for average, right? So for taking the mean or average, you just type it. But here you had a variable which is not a number. So obviously your mean is not going to produce any number. So that is not a number. But suppose forcefully you want to not consider that not a number thing. Suppose you have a missing value or do not want to consider that missing value, or you want to remove those missing values, and then you want to compute your mean. So this again is not to be done manually. This is not to be done manually. This is automatically can be done through using this command, that na.rm, that is rm for removing. So you are removing the missing values and you are setting that to true, and then obviously your mean is calculated with these 7 variables only, 8 variables only, and your mean is 4.5. Like that, you can remove the missing values from your vector or any kind of data. So what kind of data types are available in R? As you have seen that you do not need to bother about the data types, but there are different data types. You can declare, or you can build those data types in your own. There are 5 basic kinds of data in R. Firstly, vector. So each and everything is treated as a vector unless you declare them to be otherwise. So like you can declare it to be a matrix, you can define an array, you can define a list, or you can define a data frame, which is a formal definition of a table in case of R. So then what is your vector? Vector is a sequence of data elements of the same basic type. Like if you know C or Java, you must have heard about array. So because array is a collection of similar kind of elements, like if you have 5 integers, you can have 15 integers. So you can declare an array. Here, vector is the replacement of that kind of thing. It's a sequence of data elements of the same basic type. And what are the basic types you have? Your basic types mean you can build or derive type from those basic types. You have 5 basic types here, which is starting from integer, numeric, complex, character, logical. Like to declare integer, you just need to specify a capital L after the number, and that will be treated as an integer. And if you want to numeric number, that we were using, that you do not need to specify the capital L after the number, and it will be treated as a numeric number. For logical, you can write true or false. For complex, you can type like this, and for character, you can use a single quote or a double quote if you have multiple characters. So these are the kind of vectors that you can use. For matrix, matrix is our object in which elements are arranged in a 2-dimensional rectangular layer. Again, similar to your Java or your C language. So these are the objects in a 2-dimensional fashion. And for declaring a matrix, you need to use this syntax. You need to write matrix. You have your data, number of row and number of column, and you have to define how many. These are actually optional. Your dimension names and by row, these are optional. If you declare your number of row and do not define your number of column, then you need to define how many rows you need specific under a specific column. I demonstrate all these things. Now array can store data in more than 2 dimensions. In case of C, you had array of single dimension, you have array of 2 dimension, you have array of 3 dimension. You can increase the dimension even further. But here, array of a single dimension is actually preferred to be known as vector. An array of 2 dimension preferred to be known as matrix. And an array of more than 2 dimensions is actually known as an array in case of R. Okay, so here the syntax is almost similar to your matrix, but here you need to mention the dimension because the dimension is more than 2. So here, for example, if you have numbers from 0 to 15, and you are going to have 4 here. See, you have 4 different arrays of each of having 2 dimensions. Now that means you have 4 matrices here, right? And how many dimensions they have? They have 2 dimensions, 4 by 4, and then you have in those matrices are organized in a 2 by 2 fashion. So you want to write 4 by 4 by 2 by 2, and this is how your 0 to 15 is being organized. So in each of them are actually a matrix, and they are organized in a 2 by 2, that is four numbers of matrices will be there. And then coming to the list are objects which contain element of different types of. Here, different types or non-homogeneous types have been introduced. Like you can, in a same variable, you can use numbers, you can use strings, vectors, and other things. So, if you want to bring the similarities down, it will be like this can be similar to like union of structures. Like when you can have different variables in different kind of data type of variables in a under an umbrella of a single variable. So this can be similar to that. And for the syntax, you just need to type list data and see I have different kind of variable. Like I have a vector. I will show you the use of this. I have a vector 2, which is basically of type character, and then you have a vector of logical variable, and then you have a vector of all these variables, that is for two-dimensional things. So now you can prepare your my list, which is a list variable of all these three non-homogeneous kind of variables, and you can see that if you produce the my list, you are getting these results. That means you have integer variable or a numeric variable, you have a variable of character type, you have variable logical. So this is the use of list. And finally, data frame. Data frame can be considered as a table. It is a structure. It is very much useful when you are considering classification, clustering, or any other kind of data analysis part. This will be very useful in case of histogram analysis also. So it is or a bar chart also. So a data frame is a 2D structure, array-like structure. Okay, in which each column contains value of one variable and each row contains one set of values from each column. So this is like a table, right? And for the sake of syntax, you need to type data.frame, and within that you need to type the data. So this is a kind of data frame. So it looks like a table. It looks very much like an Excel table, right? You have rows where you have in rows you have different instances, and in column you have different attributes of those instances, right? So this looks like table. So data frame is actually a representation of table. Okay. So let us first demonstrate the use of tables. So here I will go to RStudio. So okay, so let us start with the basic. So after installing, you have to use the library. To load the built-in dataset, you need to go to this library option. So you just to use these options. See in the right hand corner, you have a run option, and you have options like source. So you can just click the source, and all the lines here will be run in one click. But if you want to run a specific line, you have to select that line, and you can go to click this run option, or you can also use, after selecting the line, you can also use Control Enter, and that line will be run. Okay, so let me first run the first line, which is library under dataset. These are all comments. You have to use hash for commenting any line. That line will not be running. After clicking as well, those lines will not be running. So if you just want to run this line, you just need to select this and just click on run, and then your console will open, and see no output is given, but your library datasets, after running this line, no comment is appearing or no error is appearing. That means your dataset has been loaded. So if you want to now see the so how to clear this console, because it looks messy because I had different other comments. So just you need to type just type Control L, and your console will be clear. Okay. So now to summarize the data, you need to type head and the name of the dataset. So I had IDs dataset. IDs is the name of a flower. I think you are aware of that. IDs dataset. It's a flower name where you have different characteristics of a flower, and then you need to classify the flowers, four types of flower depending upon their characteristics. Okay, so just let us see the dataset first. So to see the dataset, you need to you have options like head option, where in the head option you can see the first 6 lines of the dataset. So if you run this, you have seen the first 6 lines. So the whole dataset are not shown. Only the first 6 line has been shown. And in this 6 line, you actually are concentrating. We are actually concentrating on the column part. How many column you have? You have 1, 2, 3, 4, 5 column. And what they suggest, the first column suggests the length. So sepal length, the length of this iris flower sepal, then width of the iris flower, the petal length, and the petal width of the iris flower. So these are the 4 attributes, and the last attribute is species. That is the most important or decision attribute, I will call it. That is depending upon the length width of the sepal or length width of the petal, can you guess or can you classify the species type? So this kind of task we will be doing with the iris dataset, or you can also plot the different characteristics or attributes of the dataset. Well, that will be doing in future. But for now, you can just why do we use head command? Head command is used to just see a snapshot of the data, just for first 6 lines. But we will be concentrating on the column part actually. So how many columns we have and what they suggest. But if you want to know some basic statistics for the iris dataset, you just need to type summary of iris, and then you just run it. See, you have mean, that is the minimum of a particular attribute. You have mean, that is the average of the particular attribute, maximum of the particular attribute, and median of the attribute. So I think you are aware of mean, median, and more these things. So I'm not going into that. But very easily you can see how easily you can find those things by just typing one command, which is summary. And then you have first quartile and second quartile as well. That is the 25th and 75th. So these are the result on the variables like sepal length and width, petal length and width. And in case of species, so species is a categorical variable, right? Why it is category? Because you have 3 kind of species, which is Setosa, versicolor, and Virginica. So here you have 50, 50, 50 of all of them. So basically it's a categorical variable, so you cannot have mean, median, mode kind of thing, or first quartile, third quartile kind of thing. So this is why R is so intelligent itself, that it has understood the type of the variable, which is a category, and it has not checked for the different statistics that it had checked for other 4 variables. So this is one more positive point. And for the plots, so if you simply want to see a visualization of the data set, inspect the visualization, you need to type plot within bracket the data, and then you will see the different scatter plots that we have. So I will come to these scatter plots later. So this is just for the sake of for introducing things. And for to clear package, you need to type in this, and for clear plots, you need to just use def.off. Only if a plot is available, your plot will be cleared. Or you can also use this option, which is a task clearing option here in plot. Okay, so this was our first introduction to R and RStudio. Okay, so now I will straight away go to the data format. So, okay. So as I said, there are 5 kind of data format. You have numeric data like this. You can also have numeric data like this. So whether it's an integer or floating or a double number, you are free to write it like this. Okay. Then you have C. One thing you must have noticed is that I am using this thing, which is angle bracket and then a hyphen for taking input or making any variable assigned. So I am assigning 15 to n1 by using this angle bracket and hyphen kind of thing. So I am using, like, if you write a is equal to 5, that will be executed, and if you see the value a is equal to 5 is being assigned here in your environment. But if you need to write angle bracket and this, the same things will be done. Like if you write the b is equal to 5, in R from its very beginning, this indentation is much popular than the equal to sign. So I will encourage you, and everyone else also will encourage you to use the first option, which is this option, rather than using equal to in R. Okay, so but you are free to use equal to as well. And to check, now coming back to the data type, to check the data type of a variable, you need to write type of within bracket the data type. Like if you have, if you just run those lines, first you have to need to run those lines and see the n1 variable is coming here. Now you want to check the variable, the data type of the variable. See, the data type has been shown here as a double. So it is very intelligent in respect to, in order to check the data type of the variable as well. You do not need to write it, or you need to do not specify it at any time. Because suppose I want I have another variable which is c1, and in this variable I have c. So c, it's a character, it has been shown, right? Now I am within a double quote. In fact, within a double quote, I put only one character, and it is been shown intelligently as a character. Now see this one. I have string character, and see, it has been shown as a character. So everything is done automatically. This is a logical variable, so it must show logical, right? So these are the things, and then I will come to the vector. So in order to get a vector, or in order to assign a vector, you need to use the command c. C is for a vector. You need to define a vector. You need to use c. So within after c followed by one first order, then you have to need the variables, different variables within that vector. So I have 1, 2, 3, 4, 5, and I just check this dot vector, that is whether my b1, the variable, is a correct vector or not, and it is showing true. So this is correctly declared as vector. You can see the vector has been shown here, 1, 2, 5. Okay. In fact, a vector can be of different data type, like it can be of your character variable as well. You can have a vector of a logical variable like this. So these are the use of vector. Then you have matrix. So for matrix, I have shown that it is a 2-dimensional kind of thing, and you need to write the number of row and number of columns if you want to specify. So here you have a matrix, which is a 2-dimensional kind of vector, and you need to see this see the value after assigning. See, it is being shown in a 2-dimensional way. Right? These are the column numbers 1, 2, 3, and these are the row numbers. So you just can read like 1, 1, 1, 2, 1, 2, 1, 2, 2. And also you have a matrix of like this, and you can just type M2 and see your A, B, C, D has been defined by like your A, B, C, D, and your number of rows are 2. So this way also you can define your array. And to keep data in an array, you have to include the dimension and in format as well. So here I have an array A1 where I have two things. First, I can use this colon. I can use this colon to have a vector from 1 to 24. So I do not need to write 1, 2, 3, 24 like that. If you have a vector like from say 1 to 100, we can just write like within C, you can write 1, comma 2, comma 3, comma 4 up to 100, or else very easily you can write like this and see your variable has been created, and you can just check it here. See, 100 numbers have been created. So this way it is very easy to declare and use the vectors. Okay, so now for the next thing, so after the data type, we will discuss 9,000 plus packages in R, and they actually make you while you are using packages, you will feel like Superman, right? So now where to get those packages? You will definitely ask the question. Then where to get those marvelous packages? Well, there are some base packages. I have not installed it, but I can use it. Like you have installed R, some base packages are already there, comes with R itself. You do not need to specifically install them, you just need to load them. That is, you going to use before you just need to load them. Like the dataset package, I use library datasets, the package was pre-installed. And for the contributed packages, that those have been contributed from the community, and those actually are measured in numbers. From the 9,000 packages, 90% or more have been contributed packages. So for those packages, you need to install specifically those packages. Now the question is how you install those packages. Well, there are commands and there are GUI, both options available. But from where you are installing packages, there are three main sources of packages. First is CRAN. CRAN is the website where you have downloaded R from, and there is Crantastic, which is another website or web server where you can download, and GitHub is another primary source. Or from any other source you can install packages. So that everything is available free as far as CRAN and Crantastic are concerned. So from there you can install packages. Just for the sake of here, you can just go to your R and you have option like packages. You can install package. So before installing package, you need to select the CRAN mirrors. Okay, from CRAN mirrors, that is CRAN is the website of R. You need to select any of the mirror. Let us select the Indian mirror. So this is the Indian mirror, and after you select the Indian mirror, you have these packages. How many packages are there? So many packages. They are sorted in alphabetical order, and these are the list of packages that are available in Indian server. So you can just select any of them and click OK, and thus package will be installed. Very easy. And to load package, we going to go to package, load package, and these are the packages that are already been installed. These packages are already installed. Either these are pre-installed in my R from the beginning, else I have installed this after I have installed R. So these are the packages in my kitty, I will say, and these are available currently. So I can use them after just clicking on the package. Suppose I want to use this package, I just click on this and say OK, and that package will be loaded. So that package will be loaded. Unless that package is available in my kitty, that cannot be loaded. So after installing the package, you need to load them. And you can also update. You can select a different mirror. These kind of things are available in package. What are the other options? In RStudio, you can use the command like install dot packages, and within the bracket, within a double quote, you need to name the package, and that will be installed. So that is the second option. As a third option, you can also go to this package option, and you can type the name of the package here, and after the name appears, if it is correct, then the option will be available here. Select that and just click on install, and you can also update the existing packages. So there are so many options available to install packages. Okay. So the next thing is, okay, so the installing packages are done. Now these are the packages that have been frequently used. I use those packages frequently, and you may also use those packages. Need to use those packages very frequently, when you are using, when you are analyzing data, or in case of data science also. So what are the packages? The name are very cryptic, like DPLYR. That these packages are used to manipulate data frames. If you are using to analyze data frames, you have to use deep wire. DYDWire, this is for cleaning of informations. Stringer is used for string of text, manipulate string data. Duplicate is used for manipulating date information. ggvis, a very important package, is used for visualization. Or before analyzing, you need to visualize, right? Picture first. Picture comes way faster than the data. You can visualize the data well. You can also have a good picture of the data, and then only you can analyze them. ggplot2 is for creating beautiful graphs, 2D graphs. And finally, RDO, which is in fact R input output, is for input output of data. And you need to install and load these packages, right? You need to install and load these packages if you have not used one. So if you ask how can I install all these packages in a single click, well, you can do that. There is a package named as Pacman, and Pacman is actually a collection of all these packages. All these 7 packages are, and there are other packages also. These are available all in one single package, which is Pacman. Okay, so how to use this Pacman? You just need to install with .packages, and you can just type Pacman. So I had already installed it. So just click it and see the packages have been already loaded, so you are not installing it once. So just click it, just enter it, and your Pacman will be installed or updated. So that's all. So after installing this Pacman, you are ready to go. So just to see the use of Pacman now, let's go to here. So we will have a demonstration of how to use Pacman. So let us open a code here for your package. And okay, so see. So again, I will just go to library dataset. For that, I will just Control L to clear this thing. To go to library dataset to import your data, load your data. These are pre-installed datasets, and these are the packages. If you suppose want to clear some, at the moment you do not need this DPL-var, TDVR, and stringer package, so you can actually type like unload, and your package will be unloaded. So I have not previously loaded these packages, so these packages are not unloaded. So first I have to load the package. So after installing package, you need to use library Pacman to load the package. So to load now the packages are being loaded. No message will be shown if you click on if you run library Pacman. No message will be shown. Just the package. All the packages have been loaded. You can use this and see these packages. So there were some packages that was not earlier installed. So obviously these packages will be installed. So see, I had some packages that were not installed. So these packages is now getting installed. So you can use this to ensure that all packages have been loaded successfully. So unsuccessful things will be installed and then loaded. And then this is how you use your Pacman. Okay, now okay. So after you I'll come to this later. So now come to visualizing your data. So how do you visualize data? I can use bar chart. When we use bar chart, it's because this is the most basic graphics, the bar charts. So let us go to bar chart first. In visualization purpose, let us go to bar chart first. So let us open another one that is for your bar chart. So let us go to plot first. So okay, so I have loaded the dataset already, and I have seen the IDs dataset. Now I can go to, specifically for one variable. So species. So see, species is a categorical variable. We already have seen that species is a categorical variable. Now within the dataset, I have a IDs dataset. You can see the head IDs, and that there we have the IDs dataset. So just wait for the installation to be finished first. Okay, so after you type head IDs, so this the IDs data set has been loaded successfully. Okay. So now, suppose you want to just have a look at a variable called species. So you need to type IDs, that is the name of the data set, and then dollar. That means you are entering in the data in the IDs data set. And what are the options? You have sepal length, sepal width, petal length, petal width. And you are just, we want to see the species. Just enter and see. So you have these many species, these many rows, like 149, 150, and these are the row by row entry of the species. And suppose you want to plot one categorical variable, which is the species, and you can see, you just select that line, run it, and see the plotting comes just like this. Because I had already shown you how many Setosa and Versicolor and Virginica were there. They were all 50 equally distributed. So this is how they look like. They had all 50, 50, 50. What the interesting fact is that R itself very intelligently finds that it's a categorical variable, and I have just typed plot, and it has intelligently find that this is a, and it has visualized all the things very intelligently. Now suppose I want to visualize a quantity variable. Here my length is a quantity variable. You can check. You can go to IDs and see the sepal length, and this is a categorical variable. Sorry, quantity variable. So now, if you want to plot this quantity variable, it should not be shown in a bar chart, right? So see, we want to check whether R is intelligent enough to do that. See, because I have used the same command for different quantitative variable, unlike earlier which was a qualitative variable, and it has been shown in a scatter by default. So that is why R is so popular nowadays, because you do not need even to bother about the type of the data. You are not even bothered about the type of the variable, whether it's a categorical variable or a quantitative variable. If you just want to have a basic look of the data, do not need to care about those things. It will automatically, you just use the same command, automatically will show you the plots of the data. Okay. Okay, so that's all. Now, now let us straight away go to the bar plots. Okay, so how do you use bar plots? More customized bar charts. So here we have the bar charts, and I will load a data set here, which is empty cards data set. So what is empty cards? You just need to, if you don't need to know about more about empty cards, you just need these empty cards and see. As I said, that RStudio has a very good navigation thing available, so you do not need to go to the browser. Everything is open here, and you just see those things. So empty cards is actually, it was a data from 1974 Motor Training United States magazine, and it comprises fuel consumption and 10 aspects of automobile design and performance for 32 automobiles. So this is the description of the data set, and these are the variables, like in miles per gallon things. So these are okay, so we do not need to bother about that. Suppose you need to see here what is the CYL. CYL is the number of cylinders, right? And if you just see the number of cylinders here, the type of the variable, just need to head and empty cards, right? The cylinder here 6, 6, 4, 6, 8. So this is a quantitative variable or a numerical variable, right? So, and you want to plot a bar chart of that. But numerical variable do not have part, do not basically they do not fit in bar charts. So what will happen if I forcefully want, because if I just need empty cards dollar dot cyl is number of cylinder. So this is a scatter plot. But here you can specifically see within this scatter plot. Well, my dear friend, this is actually not a quantitative variable. Why? Because I can see there are three number of cylinder available. Only there are car with 4 cylinder, car with 6 cylinder, or car with 8 cylinder. So, well, can I have a bar plot of that? That is how many 4 cylinder variables are there, cars were there, how many 6 cylinder cars were there, how many 8 cylinder cars were there. So unless and until you have a bar plot, you cannot get understanding or clear picture of that, right? So can we have that? So forcefully, I want to have a bar plot. What happens? Let us do that. Oh, this is not working. This is not working at all. It is more worse than a scatter. So where the things are going on? Because I am doing it forcefully. I want to do it more delicately. How to do it more delicately? You can form a data frame or a table with that, and a simple table command will do. Let us build a table, create a table with this. So I just need to type table, and within this, and I just taking it into variable cylinders. Just run this line and see here a variable has been created. Right here, a variable, a table is being created, and you can just visualize this table. Okay, see. How many 4 cylinders were there? 11. How many 6 cylinders were there? 7. And how many 8 cylinders were there? 14. So automatically a table is created. Now I can have a bar plot and just run with cylinders. See, the things are working. So now you have 4, 6, and 8 underneath, and you can clearly see how many numbers of 4, 6, and 8 with the cylinder variation variant card were there. So this is how you can specifically use your bar chart command. Or after creating a table for a quantitative variable as well, if you are sure about the fact that this is not a quantitative, in fact it's a qualitative variable, so you can actually create a table from that, and you are free to bar. Okay. Next thing we'll go to is histograms. So why do you use histogram? When do you use histogram? In case of quantitative, scale, measure, or interval ratio levels. So let us go to R itself and exploit with histogram. So here you have so this is with IDIS dataset itself. I can create histogram, and I have the sepal length, sepal width, length, petal length, and petal width, and let us create histogram and look to see their distribution. Like in histogram, basically we check for the distribution. So let us just go with this and see. So this is the histogram of your length of the sepal, and you can see in this histogram, the length starts from 4 and continues up to 8, and these are the frequencies. How many 4 lengths were there, how many 5 lengths were there, up to how many 8 lengths were there, like that. So you can actually study the frequencies and distributions with the help of histogram. And you can also create like this. So this is more close to a normal distribution. So these are the things, the idea you can have from visualization. Right. You can carry on doing that. So basically, what a data analyst do or a statistician do before going into any kind of programming or any kind of further statistical analysis, they want to quickly visualize. And for quick visualization purpose, what language do they prefer? Do they go to C or Java? No, because that will take much time. Before going into anything, if you want to check a quick visualization, they will prefer this R, because everything is available freely and everything available in their hand. And most interestingly, they do not need to write any kind of code, and they do not need to bother about the type of the data or the variable. Okay. So, and finally, what are the other kind of things? You have scatter plot. Scatter plot is used to visualize the correlation, association between different quantitative variables. So, let us go to just demonstrate the scatter plot. So, this is the scatter. So, for that, I will use the empty cards data set, and I have I quickly want to check the distribution of your weight and mile per gallon. Just see your weight. This is your weight, and concentrate on this lower part, this weight and your mile per gallon. And then this is your mile per gallon. Now, then we are interested in finding whether the weight of the car has any role to play with mile per gallon, or or do they have any correlation or association between them. There, you need to plot them both, right? And this is how they look like. Oh, they have a correlation, right? If you have an understanding of correlation, this is the kind of negative correlation that you have. That means, as the weight of the car increasing, the fuel efficiency, that is mile per gallon, is decreasing. So that is why I am telling from the beginning that visualization is so very important, and an easy tool is very much required for visualization, quick visualization. You do not need to write any programming or any coding. From the beginning, I have not written a single line of code. This is not coding. Yeah. So this is only just I am using only some basic commands that is available now, and I can do very in-depth analysis of my data by just using this simple line of codes, line of commands. Okay. Now I will introduce into another very useful. So a few of you may be familiar of using SPSS, Stata kind of thing, and you may be wondering where are those simple options, right? Where are those simple options? Those are available in SPSS. I need to even write some commands. I do not write any command in SPSS, right? I can only use GUI. I am not familiar of using commands. I am familiar only with GUI. Well, dear friend, you have option of that as well. So for that, just need to go to this R, go to the packages and install packages. You need to install a package, this one, RCMDR or R Commander. Okay, so I think I have already installed this package. So you have to select this from here and then install. After installing, you need to go to load package. And from the load package, if you have already installed it, it should be available. So this is the package RCM here. Click on that, and the window should open. So it is taking time, but the window will open. And window like your SPSS with full of GUI things available will open, like this. So this is a window having see there are so many graphical user interface available. And here, just for quick visualization purpose, import your data, your own data. But here I will just go for the already available data. So how many data sets are we available? To see the data set, you want to go to the option data. You go to data in packages option, and there you have option list data sets in packages or read data set from packages. So you can quickly check for the list. So here are the list of data. Already familiar with IDs and empty card data set from the beginning. So let us check whether these are available. Well, IDs data set is available. So IDs data set is available within which package? See, the IDs data set is available within the data sets package. So let us close this window. Go to that window again, uncomment that. So data set in packages. Now we can choose to read. So I will choose these data sets, right? And now we can use IDs data set. Just select the IDs data set. It should be available. Well, so cannot find, you can just name it. So is it available in the dataset package? Is it available in the sandwich package? Let us see it again. Go to data, active data setting packages, keep the list of data set. So where we have okay, go to this one, IDs. Is it available? Air quality IDs, these data sets are available in data sets. So so air passenger data is available here. This is the very data set. Air quality data set IDs is there. Yes, IDs is there. Okay. So now see, I have not write any kind of code. I have not neither write any kind of command. I have just used simple GUI, and the dataset is already loaded, right? And suppose you want to check the basic statistics of the data and want to summary of the active data. So you can just click on the statistics and summaries of the active data and see the summary is available. So this R commander is a very nice gift for those who do not like to write any kind of code or command. This is only available in GUI, graphical user interface. By using some very basic clicks, you can analyze your data. Even not basic analysis, you can have like different parametrics and non-parametric tests. Some of you may be aware of different parametric and non-parametric tests. You can use ANOVA, t-test. Some of you are scholars then of data science or students of science, data science or statistics. You may be aware of these facts. This ANOVA, t-test, all those things. So all these options are very easily available by in some clicks. You even do not need to write any command. Okay, you can check variance, keenness, all these things. So this is very interesting. I will encourage you to explore this thing, R commander, where you do not need to write any kind of code, any kind of command. You just need to simply use GUI, and all the things are available at your fingertips. Okay. The next thing, I'm just giving some overview. I'm not giving all this. So we are coming at the very end. So this, okay. So one more thing before concluding, use of one more package. I think. Describe. Okay, so if you want to if you do not want to install R commander, all these things are also available in a package called Site or PSYCH or Site package. In the Site package, you can have a command like describe, a command called describe. So if you already have installed Pacman, you do not need to install it again. So you can just need to load the package, and I have just loaded the package using this command. And after loading the package, I will use the command describe. Suppose you use the command summary of your say IDs data and IDs data sets sepal length. The summary is showing few things like mean, your first quartile, median, mean, third quartile, and maximum. But suppose you want to get data, suppose you want to know the data in much detail, then we can use the command describe. And by describe, the same thing of your IDs sepal length, you have various other things like your trimmed 15% or 20% trimmed, your mean, max, range, skew, kurtosis, variations, variance, standard deviations, everything. Everything that you want to know about distribution of a data, that you can check quickly by using a single command, which is test file. And finally, after using all these things, you want to clear your environment, you can just type this command. After all these things will be cleared, you want to clear these lots, and then you to clear all the packages, you just want to write those line, and you will clear the console. You can also type Control L, and your things are all cleared. Now you can clear your plots and things. These are all okay. So now at the very end, I will just end with one more thing, which is another very good style of writing programming in R, without which some Python user may not want to move to R. Is this: in the new file you can open a notebook. So those who are familiar with Python notebook actually have the same test or same issues here in R notebook as well. So there you can clear all these things. You can clear all those things. Here, if you want to write any line of code, here you just want to go there and select. You can even run other programming languages like Python, C++, SQL, etc. But for the time, just get a new code of R. So here you can write any code, like you can import your dataset. Here you can import your datasets. You can plot for variables. These things you can do, and specifically after doing, you can just write your own line that will not be run. Okay, like playing without. So this is another option that you can very easily use, and very easily you can run those line of codes by just clicking this. And this, the most effective part of this is that, see, after you are running the code, this is not going into the console, right? Still the console is clear. If you just see, the console is clear. Console is not showing anything. All the output are not going into the plot as well. Neither is going to the environment. All the output are coming in your notebook. This is almost like your exercise book or notebook. You're taking note of things, and everything is coming inside your notebook. You want to share this, you can preview the notebook, and you can save the notebook here. You just save it, and your notebook will be saved. And you can share the notebook itself with all your commands, codes, and the output. This is very helpful in research purpose as well, because you are having the codes, data, output within a single umbrella. That is your notebook. Later, if you want to check the input, output, commands, everything, data, you have to just open the notebook itself. You do not need to go to any other directories. So this is very useful thing. And Python, you had Python notebook here, and R you also have R. So last thing, finally, if you want to learn more about art and data science, which is a buzzword nowadays, our university is launching a course which is a diploma in data science. It is a 1-year course. So very basically, data science is why it is a buzzword nowadays, because it is the center of attention of computer scientists, of statistical mathematicians, business classes, and because it is intersection of your machine learning, business analytics, database management systems, computer science. So many things are there and merged into one subject, which is called data science. So it is a very promising subject nowadays, and you will not find many institutions to learn data science within a year, which is a diploma course. So I hope this will be very interesting to you all. And most interesting part is that this course is evening course. So if you are doing any other degree courses, BSc, MSc, if you are a research scholar or a working professional, you are free to join this course. Uh, you do not need to discontinue any other course that you are currently doing. With the course you are currently doing, you can do this course as well in evening. The classes will be preferably on 3 weekdays only, and from 4:30 to 6:30 only, 2 hours of classes and 2 semesters it involves. You can go check the admission notification in our website. It is available. So let me just close this. So the admission is currently going on, and it will go up to 5th of September. So just let me quickly show the admission notification for available. So this is the admission notification. So admission, this course is running under CCAE. The fee is very nominal, just 12,000 for 2 semesters, and 200 is the admission fee. And I am talking about this course, diploma of 1 year, 4 days a week, and this is running under CCAE, and it's a PG diploma course under CCAE. It's an evening certificate course. So classes will be 4 days and 4 days 2 hours per day. So you are welcome to join this course. And if you have now, I am open to any question or queries regarding the hands-on session or the course as well.